Today we're going to look at applying a few more laws of exponents. So this from the textbook, which is on page 23. You want to refer to that. So the power of a product. So you haven't seen these yet. You've seen powers that are applied to one of the parts, one of the factors that are inside brackets, but this is where you have a product, so a multiplication inside brackets and then an exponent outside. So what this means, for instance, if I've got x multiplied by y, and let's just say that m was a 3, what that means is we've got x, y multiplied by x, y multiplied by x, y. So x, y is just multiplication, so that's x times y times x times y times x times y, which if we collect things together, okay, we get x to the power of 3 and y to the power of 3. So that's how it's broken up and explained, but the shortcut is basically to say that this exponent gets applied to both of those separately. So you can see that the 3 ends up with the y, the 3 ends up in the x, and the brackets have gone. Okay, so for example, if we've got another one like 2a and it's to the power of 4, that would become 2 to the power of 4, a to the power of 4. Now a to the power of 4 we can't do anything about, but 2 to the power of 4 we can simplify, because 2 to the power of 4, hopefully you'll all know, is 16. So we end up with 16 a to the power of 4. So the 4 goes to the a and the 4 applies to the 2, but because 2 is a number, we can actually simplify that and get rid of the exponent, but the a keeps the exponent. The next one to look at is the power of a quotient. So if we look at this, let's take a fraction like 2 thirds, so x and y, 2 and 3, and then let's raise that to the power of, let's do 3 again. Okay, so what does that mean? Well, that would be 2 thirds multiplied by 2 thirds multiplied by 2 thirds. And hopefully you'll remember from your fraction work that when you multiply fractions, you multiply the numerators and you multiply the denominators. So without working that out, you can now see, well, that could be written as 2 cubed over 3 cubed, which could be simplified to 8 over 27. But this is the bit I'm interested in this time round, because you can see that the 3 has applied to the numerator and the denominator separately. So in this case, if we generalize it, x divided by y to the power of m becomes x to the power of m divided by y to the power of m. Right? In the same thing we did before, if you have something like 3 over x all raised to the power of 2, well, that would become 3 squared over x squared, which could then be simplified to 9 over x squared. So you can deal with the number to make it a little bit more simplified, but the variable, the letter, we can't do anything about. The next one to consider is the power of a power. So let's look at it. If we've got something like x to the power of 3, we know that that's x times x times x, right? But if we've got x squared and then to the power of 3, well, we just replace the x's with our x squareds. So it becomes x squared cubed. So x squared times x squared times x squared. Right, sorry about that. So that means we've got whatever's in the brackets has to be cubed, so multiplied by itself 3 times. We can simplify that because we've got that power rule that we've used before, where you add the exponents together, right, as long as you've got the same base. So that then becomes x to the power of 6, which you might then notice is the same thing as if we multiply those two numbers together. So we actually end up with x to the power of 2 multiplied by 3, which gives us the 6. A lot of people forget and they think, oh, I'm adding powers together, but this power of a power 1, you actually multiply. All right, so what we can actually do then is we can think about applying that to something like, well, let's say we have 3 to the power of 2 divided by x, and all of that is raised to the power of 3. So now we've got the mix of outside brackets and fractions, but it's the same thing. So we would do the 3 applies here, but because we've got 2 exponents, we multiply. So it'd be 3 to the power of 2 times 3. But in this case, well, there's no exponent, but we can treat it as a 1. So that would be x to the power of 1 times 3, which would end up being 3 to the power of 6 divided by x cubed. Okay, I'm not going to worry about 3 to the power of 6 because I want to show you the powers. Okay, if we combine it even further, well, let's say we had something like 2x squared over 4. Actually, that can be simplified. Let's do over 3. That's all raised to the power of 2. Now we're starting to combine lots of different things. So now we use our power of a product. So the 2 applies to the 2 and this squared and this 3. So we end up with 2 squared. X to the power of 2 times 2 is 4, all over 3 squared. So we end up with 2 squared is 4, x to the power of 4, 3 squared is 9. Okay. What a lot of people forget to do is apply it to the number. They sort of remember to do it to this bit, the x squared squared, but they forget to apply it to the 2 quite often. And the final one to look at is this roots as exponents. So good if you can do this through investigation, but I'm just going to tell you what it is. So this one, the square root of x, well, that is equivalent to having a half. We could try and explain it, but maybe we'll do it in a setting where we're all together and we can chat about it. So that would be x to the power of a half. And now the next one, the x cubed, x to the power of, well, the cube root of x, not x to the power. So that would be x to the power of 1/3. Okay. Now the 3 becomes the denominator. So here x squared, we don't ever bother with the 2. We just recognize it as a 2. So that's never there, but that's where the 2 comes from. So following that through, if I've got any root, so let's say there's an m root, the x will be applied like this. So it'll be x to the power of 1 over m. There are other levels to that, but that's basically what happens. So just as an extra, well, let's say if we have the cube, I'll write it somewhere else. Let's apply a couple of things together. So if we have the cube root of x to the power of 2, what we can do is think of that as brackets, and then this bit can be changed to an exponent. So this would become x to the power of 2, all to the power of 1/3. So this bit became the brackets and that. Now we apply the power to the power rule. So that would become x to the power of 2 times 1/3, which is x to the power of 2/3. So there's just a little showing how things can be put together. Okay, so here's one of the examples in the textbook, so you can follow through what they say, but I thought I would go through this one with you. All right, so first of all, we've got a power outside of some brackets, so and we've got a fraction. So what we know is that this 3 will be applied to all parts on the top and all parts underneath. So we've got to be careful that we identify everything. So we've got the 3, lots of colours going, we've got the I cubed, we've got the j squared, we've got the k to the power of 4, and actually I can use that j because we've got another j, and then we've also got another I squared. So what we've got lots of options here. We could apply all this and then simplify, or we could simplify first. So let's do both. So if I apply it one step at a time, so it'd be 3 cubed, the 3 with the 3. I cubed, so we do 3 times 3, so that's I to the power of 9. J, 2 times 3 would be j to the power of 6, not 5. I'm sure some of you will write 5 at some point. I squared, applied the 3. 3 times 2 is I to the power of 6. Then we've got j with the 3, so that's just j. 1 times 3 is j to the power of 3. K to the power of 4, so that's k to the power of 12, because it's 4 times 3. Okay, so now we can simplify. All right, so 3 to the power of 3 is 27. Can't do anything, there's nothing to simplify there, but that's dealt with. I to the power of 9 divided by I to the power of 6. Well, when you're dividing, you're subtracting, so that would be I to the power of 9 minus 6 would be 3. Okay, j, so 6 divided by 3. So 6 minus 3 would be 3, j to the power of 3. And then the k squared, nothing's happening with that, so that one stays where it is. So that would be our final simplified version. I haven't written all of that out, so while I've been talking, if you want to pause that and go through it and make sure. So it was this dealt with 27, I to the power of 9 divided by I to the power of 6. Well, that's I to the power of 9 minus 6. And j's, the j to the power of 6 divided by j to the power of 3. Here, look. So, well, that would be j to the power of 6 minus 3 is j to the power of 3. Okay. Of course, we could have done it by simplifying beforehand. So simplifying beforehand, I would have just done 3, well, t cubed, t squared. I would have just done subtraction there. So I would end up with 3 minus 2 makes t to the power of 1. Then the j squared and j, well, 2 minus 1 makes j to the power of 1. And then we've still got the k to the power of 4. But all of that is still to the power of 3. So then we multiply, or apply the exponent to each one. So that would be 3 to the power of 3. T, was that t? That should be an I, not a t. Why did I start writing t's? I to the power of 3, should be an I, j to the power of 3, and this would be k to the power of 12, 4 times 3, which you can see is the same thing. I just haven't done the 27 yet. So you can apply it before or after the simplification. It's entirely up to you.